In this video, we're going to solve Math 1100 tutorial sheet 1. This is your tutorial sheet for 2026. Now, before we even solve all these questions, don't forget to subscribe to our channel. You can also comment and also like this video. So let's start with the first question. So we are told to list the elements of each of the following sets. We've been given P, 1, 2, 3, and the list is going. Then A is that, B is that, C and D and that. So we are listing the elements of each of the following set. So let's start with the first one. So for A, we are told that our X is such that X is a member of P. Then this X is such that X is greater than 3 but X is less than 12. So how are we going to solve this? If we're going to look at P we've got 1, 2, 3 and it's going like that. These ones are positive integers. So P is a set of positive integers. So therefore, if we're going to look at X, it being a member of P there, X must be an integer that is greater than 3 and less than 12. The integers that are satisfying this condition, we've got 4, we've got 5, we've got 6, we've got 7, 8, 9, 10, and 11. So those are the integers that are going to satisfy that condition. So A is going to be that. Okay, let's solve B. B, we are saying X is such that X is a member of P and this X is an even or is even, and X is less than 15. Okay, so here we're talking about positive even integers that are less than 15. However, if you're going to look at P starts from 1 and it goes all the way. Then we're saying X should be a member of P. So we're getting numbers that are less than 15. However, we're getting specifically only even numbers. Even numbers are those numbers that are divisible by 2. We've got 0, we've got 2, 4, 6, 8, 10, 12, like that. These are the even numbers that we're supposed to consider. Now, from that list, which ones are going to be less than 15? So in this case, B therefore just B. We're going to start, since 1 is not an even number, so we're going to start with 2. So B will be 2, 4, 6, 8, 10, 12, and 14. So that will be the solution for B. We come to C. C, we're saying X is such that this X is a member of P and we have an equation 4 plus X is equals to 3. So what should we do? So we have to first solve this equation. We see what it gives us. So we've got 4 plus X is equals to 3. Now if I put the like terms together, I'm going to have X is equals to 3. When I take the X, the 4 to the other side, it becomes negative. So I'm going to have a negative 4 there. Therefore, X will be equals to 3 minus 4, that is a negative 1. But if X is negative 1, look at P. There is no negative 1 in this, P. Since P has only positive integers, so no elements satisfy this one. So therefore C is equals to an empty set. Okay, or you can denote it like that using the braces. So basically that, let's solve D. So for D we are told that X is such that X is a member of P, and this X is a multiple of 5. Okay, so in this case, since the members of P are positive integers, so we're just getting positive multiples of 5. So in this case, what are they? So D will just be equals to, we're going to start from 5 itself. Okay, we're going to go to 10, 15, those numbers where 5 can go into, 20, 25. Okay, since they haven't specified where we're ending, I can just put dots like that. Okay, basically that is how we solve D. Let's go to the second question. Question number 2 says, in the problems below, one of the following relations is true. A is a proper subset of B, A is equals to B, A is not equals to B, B is a proper subset of A. Then we are told to write the correct relation in each case. So those are the questions that we've been given. So we are literally comparing A and B. So we're going to be solving A first. We find the answer and we compare it with the answer we're going to find for B. So let's start with the first question. So A, in this case, we're saying X. Okay, we've got 2x plus 3 is equals to 11 minus 2x. So I'm going to first solve the equation. 2x plus 3 is equals to 11 minus 2x. Now if I put the like terms together, I'm going to have 2x. When the negative 2x comes to the other side, it becomes a positive 2x, equals to 11. When the 3 goes to the other side, it becomes negative 3. Now I'm going to have 2x plus 2x, that is a 4x. This will be equals to 11 minus 3, that will give me an 8. Now I'm going to divide by 4 on both sides, so therefore x will just going to give me 8 divided by 4, that will just give me a 2. Okay, so therefore A in this case is giving us 2. Okay, now we come to B. B, we've got the equation for B, we've got 5x plus 4 is equals to x plus 12. So we're supposed to solve this equation. I'm going to put the like terms. I'm going to have 5x minus x will be equals to 12. When the 4 goes to the other side, it becomes negative 4. So I'm going to have negative 4. 5x minus x, that is 4x. That will be equals to 12 minus 4, that is an 8. Then when I divide by 4 on both sides, I'm just going to have my x to be equals to 2. Okay, therefore we're able to see that B is also equals to 2. Okay, since A is equals to 2 and B is also equals to 2, so what would be our conclusion in this case? For the first expression, A will be equals to B. So the relation it satisfies is this one. Okay, so let's also review the other ones. Okay, so we've got B, we've got x squared plus 4 is equals to 4t minus 5x. Okay, so we're also supposed to solve this one. Now I'm supposed to arrange it nicely. I'm going to have x squared minus the 5x. When it goes on the other side, it becomes positive. So I'm going to have positive 5x. Then I'm going to have plus 4. Then when the 40 goes to the other side, it becomes negative 40. This whole expression is goes to 0. I'm going to have x squared plus 5x. 4 minus 40, that will give me a negative 36. This will be equals to 0. Now you're supposed to solve this quadratic. I'm going to use the product, the sum, and the factor method. In this case, the product is the coefficient of a, or the coefficient of x squared, and c. C is a constant in this case, so we've got 1 multiplied by negative 36. That is going to give me negative 36. And then for the factor, or the sum, is just the coefficient of x, which is 5. Then I'm going to look for two numbers that I'll multiply. They'll give me negative 36. But when I add those numbers, they'll give me a 5. So a 9 and a negative 4, they're able to do that. You know that when I subtract them, they'll give us a 5. But when we multiply them, they'll give us a negative 36. So therefore, in this case, we're going to have x plus 9, x minus 4, and this will be equals to 0. Now you know what this expression means. It just means that x plus 9 is equals to 0 and x minus 4 is equals to 0. Therefore, what will be the final values of x? Okay, allow me to rub on the top part. The final values of x now will be equals to negative 9 and x will be equals to 4. Okay, so if those are the answers for x, there are two answers, so therefore our a in this case will be, it's going to be starting with the smaller number, which is negative 9, 4. Okay, so we found our a. Let's solve b. For b, we are given 3 plus 2x. We're saying this is equals to 11, so we're just supposed to solve that. So I'm going to have 2x is equals to 11. The 3 is going to go to the other side, and it's going to become negative 3. So I'm going to have 2x is equals to 11 minus 3, that is an 8. 2 divided on both sides. I'm just going to have x is equals to 8 divided by 2, that is a 4. b therefore now is just a 4. Okay, so now what are we going to conclude? We're able to see that b is only 4, but a is, it has elements negative 9 and 4. So which one is a bigger set between the two? You're able to see that a is a bigger set. Therefore, the conclusion will be b is a proper subset of a. So the condition it satisfies, it's this one. So that is how we solve b. Let's solve c. So for c, we have x plus 4 is equals to x plus 4. Okay, this is a. In this case, I'm just going to call it as a, then this other side will be b. Okay, just for illustration's sake. So in this case, what are we going to do? We solve also this equation. So I'm going to have x plus 4 is equals to, when the x distributes in the brackets, I'm going to have x squared plus 4x. Then I put the like terms together. I'm going to take everything to the other side. Okay, so I'm going to remain with 0 because to x squared plus 4x. When the x goes to the other side, it becomes negative x. When the 4 goes to the other side, it becomes negative 4. Okay, I'm going to have 0 is equals to x squared. 4x minus x, that will just give us plus 3x minus 4. So this is the equation that we have. So again, I'm going to try the product, the sum, and the factor method. Okay, so of course you can solve these quadratics using any method that is convenient with you. You can use completing the square. You can also use the formula method. But for this one, I think I'll just go for this one because it's simpler. So we are saying the product, in this case it is -4, the sum is 3. Then we're going to look for two numbers. When we multiply them, they'll give us -4, but when we add them, they'll give us a 3. So I think a 4 and a -1 are able to achieve that, because when we add the two, they'll give us a 3, but when we multiply the two, they'll give us a -4. So in this case, I'm now going to have what? I'm going to have x plus 4, x minus 1 is equals to 0. So x plus 4 is equals to 0, x minus 1 is equals to 0. Therefore, x will be equals to -4 and x will be equals to 1. So those are the solutions that I have for A. So allow me to just rub this and write on the other side. So I'm saying A, we have -4, 1. Okay, so let's try the other side. We've been given x squared plus 3x minus 4 is equals to 0. Okay, so basically I think that's what we had also for the previous one, because let's see, the product will be equals to 1 multiplied by, that is -4, the sum is 3, the factors, it will be the same 4 and -1. Yeah, so basically, yeah, so this is also giving us the same answer actually. Okay, if we solve this, so B is equals to, we have -4, 1. Since A and B, they are the same, so in this case, what is our conclusion? Our conclusion is A is equals to B. So it satisfies this condition as well. Okay, let's solve D. So for D, we have x plus 4 is equals to x plus 4. Okay, that is C actually. I'm writing C. So for D, we have x minus 1 is equals to 0. Then another value of x is x minus 2 is equals to 0. Then we're finding the union between the two. So this is not very hard. We're just going to make x a subject. So x will be equals to 1 for the first one. The other one, x will be equals to 2. Okay, so A therefore now will just be 1 and 2. Those are the elements in A. We come to B. B, we've got x squared minus 3x plus 2 is equals to 0. So we are solving this one. Okay, so how are we going to solve that? So likewise, we just have to find the product, the sum, and the factors. So the product, in this case, it is 2. The factor is -3. The sum actually. Then the factors, two numbers, when we multiply them, they'll give us a 2, but when you add them, they'll give us a -3. So I think -1 and -2 are able to do that. So in this case, it will be x minus 1, x minus 2. It will be equals to 0. So therefore, x will be equals to 1 and x will be equals to 2. So B therefore now will be equals to, so we're able to see that we've got 1 and 2, and this is equals to that. So they are the same, so it also satisfies this condition there. Then let's solve the last one here. So for the last one, we have x plus 3 is equals to 4, that is A. So I'm going to make x a subject to the formula. In this case, it will be x4 minus 3, which will give us x to be equals to 1. So therefore, A in this case is, it only has one element, 1. Okay. Then I come to the other one. I've got x plus 3. Then there's a square outside is equals to 16. Then you know how we solve this one. I just have to square root on both sides. So this the square and the root are going to cancel. I'm going to have x plus 3 is equals to the square root of 16 is positive or minus 4. Then what do I do? X will be equals to x plus 3 will be equals to positive 4. Another value of x will be x plus 3 is equals to negative 4. So therefore x is equals to 4 minus 3. So x will be equals to 1 for the first answer. The second answer it will be x is equals to negative 4 minus 3. X therefore will be equals to negative 7. Okay, so the values of b in this case, it is we have only 1 and negative 7. However, I'm going to start with the smallest one, which is negative 7. So negative 7 and 1. Okay, those are the values of b. Now, if we're going to compare a and b, what is our conclusion? So we're saying b is equals to negative 7 and 1. So what is the conclusion? In a we only have one element, which is 1, and in b we also have 1, but b also has 7. So since a is a smaller set in b, so therefore what is it going to be? A will be a proper subset of b. So basically this is how we solve this type of question. Not very complicated. So we are going to go to question number 3. We are told to consider the following sets. So there is an empty set there, there is A, there is B. We've been given those sets. We are told to insert the correct symbols, the subset, not a subset, between each of the following pair of sets. Okay, so they've given us an empty set and A. So what symbol are we going to put there? Okay, so let's check an empty set and A. Now we know that an empty set, every set conventionally right now, they've made it an empty set is part of it. Okay, so in this case, an empty set for A, an empty set will be a subset of A. Okay, that is that. Yeah, so that is for the first one. So it will be a subset of A. Then we come to B. We've got A and B. Now A we are saying it is only 1. B we are saying it is 1 and 3. So we're able to see that A is also found in B. So therefore A will just be a subset of B. Okay, if you are going to maybe draw it on the Venn diagram. Okay, so this can be your A there and this can be your B. So you can have A here where we only have one element, which is 1. Then in B we also have, let's say that is 3. Yeah, so basically you can also represent it like that. That's what it means. Then we come to C. C we have B and C. So if we're going to look at B and C, B we've been given that it is 1 and 3. C we've been given that it is 1, 5, and you have a 9 there. Okay, so how do we solve this one? So we have 1 there, we also have 1 there. We have 3 there, here we don't have a 3. So there's nothing common between these two sets. Nothing is really common. So in this case, the symbol that we are going to use, B, is not a subset of C, or the opposite. Okay, so it's not, you put that symbol there. Then we come to D. D we've got B and E. Okay, so this is our B and this is our E. So let's just try to compare these ones. So we're trying to find okay, so in B we have 1 and we have 3. In E we have 1 and 3. Since E is a bigger set, so in this case, in terms of representation, B will just be a subset of E. Okay, we come to the other one. We've got E. We've got C and D. C, D. C, we have 1. D, we have 1. C, we have 5. D, we have 5 as well. Then C, we have 9. Then we don't have 9 on the other side. So basically, there's nothing common between these ones. Okay? So what are we going to so there's no symbol that is going to apply here. None of them is going to apply. Okay, then we're going to use this symbol actually. Nothing is even a subset of each other. So basically that. Then we've got C and E. So C is a bigger set, then C is a smaller set. Everything that is in C, I think, is also in. We've got 1 here, we've got 1. We've got 5 there, we've got 5. We've got 9 there, we've got 9. So C will also be a subset of E. Then for D and E, what can we conclude? D, it is 1, 2, 3, 4, 5. E is 1, 3, 5, 7. So you're able to see that there's nothing common between these two sets. So none is even a subset of the other one. Then we have H, D, and U. Now the universal set is a bigger one, so every set will be a subset of it. Okay, so in this case D will just be a subset, to be a subset of the universal set. So basically that. So that's how we solve question number 3. Let's move on to question number 4. So we're told to let the universal set to be 1, 2, 3. So those are positive integers. B the universal set, and let A to be this, B is that, and C is that. Then we're trying to find A intersection B and A intersection C, then A union B and A union C. Okay, so let's just start with the first one. So we have A intersection B. So how are we going to solve this one? So what is A? Okay, and what is found in B? So what is just common between the two sets? So we can even just do it from here. In A we have 1, in B we don't have 1, so 1 doesn't apply. In A we have 2, in B we also have 2. In A we have 5, in B we have 5. In A we have 6, in B we have 7. So the only two common elements there, we only have 2 and 5. So that would be A intersection B. Then what about the second one is A intersection C? How are we going to solve this one? So we're trying also to find between A and C. So in A we have 1, in C we have 1. We don't have 3 in both sets. Oh, in C we have 3, but in A we don't have. Then we have 5 in C, we have 5 in A. So in this case, what are the common elements that are found in both sets? So we have 1, 5. Okay, so we are done with A. Let's come to question B. Question B is here. We have A union B. Now A union B are just combining what you have in A and B. You just don't have to repeat the elements. So in this case, in A we've got 1, we've got 2. Do you have a 3 in B? No. So I'm going to have a 5, 5, 6, 7. 7 is in B. So basically that would be A union B. What about A union C? A union C, it's going to be, so in A we have 1, also in C we have 1. So we have 2 in A, we have 3 in C. We don't have a 4, so we have a 5. We have 5 in both. We have 6 in A, we have 7 in C, we have 9 in C. So basically that would be that. Then the last question, I presume the last question on this one, we've got C, we've got A complement and C complement. Now A complement all positive integers except those ones we have in A. So the ones we have in A is 1, 2, 5 and 6. So in this case, what are those ones which are not found there? Okay, the universal set we've been given, we've got 1, 2, 3. Okay, until to wherever we are ending. So in this case, what are we going to have? I'm going to have A complement. So 3 is not in A. Which other one? 4 is not in A. 7 is not in A. 8, 9, 10, 11. I can be going like that. Okay, so that is A complement. What about C complement? C complement all positive integers except these ones that we've been given. So what are those ones? We're going to have a 2, we're going to have a 4, 6, 8, 10, 11, 12, and we can be going like that. All positive integers except these ones. Okay, so basically that is how we solve this part. Let's go to question number 5. Okay, so question number 5, we are given the universal set 1 to 10, B the universal set, then set A is that, B is that, and C is that. Then we're finding the following sets. So let's start with the first one. We've got A intersection B complement, then we have a complement outside. Now there are different ways of solving this one. Distribute the complement and you solve like that. But for me, I'm going to first just solve what is in the bracket and I find the complement of that. Okay, so A, okay, we've been given A. So in this case, what are we going to have? So let me start with B complement. Okay, B complement will be equals to everything that is not 2, 4, 6, 8 will be B complement, and it should be in this range 1 to 10. So in this case, so since we're starting at 2 in B, so it means B1 will be part of B complement. We're going to have a 3, we're going to have a 5, we're going to have a 7, we're going to have a 9 and a 10 itself. That is B complement. Now we're trying to find there is an intersection here between A and B complement. A is A we have been given is 1, 3, 6, 8, 10. So what is the intersection between these ones? So I've got 1, 1, I've got 3, 3. Which other one? I've got 10 and I've got a 10 there. So in this case, A intersection B complement is equals to 1, 3, 8. Oh, 10 actually. So I'm going to put 10 here. So these are the ones that we have. Now we're trying to, there's a complement here. So now when you now list the full set, it will be A intersection B. Okay, A intersection B complement. Then there's a complement outside will be. So we're looking for everything that is not 1, 3, and 10. So in this case, what are those elements? So we can start. Of course, they should be in this, region or in that range. So we're going to start, since there's 1 there, we're going to start with 2. Then we're going to move to 4, 5, 6, 7, 8, 9. Okay, so those ones will be our answers. Then we come to B. Okay, so for B, we have A complement, union B, then there's a complement outside. So you can also solve this one in different ways, okay? You distribute the complement, you solve all like that. but I'm just going to go with the way it is. I'm going to start with A complement. I list it and I unite it with B. A complement, everything that is not A, everything that is not in that region. So there's what are they? So I'm going, there's 2, there's 4, there's 5, there's 7, and there's what? Okay, A, there's 10, so there's 9 as well. So that is A complement. Then we come to, we're uniting this one with B. Now B, it is B is 2, 4, 6, 8. Since we're finding the union between the two, so therefore A complement union B will just be equals to, so let me just list this set. I'm going to have 2, I'm going to have 4, 5, 6, 7, 8, and 9. Okay, yeah. Hope we haven't missed any. I've got A complement union B. Don't forget there's a complement now, so we're going to include the complement now and find the whole set. Everything that is not in this set is what we are looking for as our final answer. So in this case, what will be that? We've got a 1, we've got a 3, and I think we've got a 10. Yeah, so basically that is how we solve this one. Okay, then we have a C. How do we solve C? We've got A intersection B union C. Okay, so what is A intersection B? What is common between the two sets? So let me start with A union or A intersection B. In this case, what is common? Let's start with where's B? Okay, so we've got 1 in A, we don't have 1 in B. So we which elements directly? We've got 6 there, we've got 6 there, we've got 8 here, we've got 8. Okay, so we only have 2 that are common in both sets. So we have 6, 8. Okay, now what about C? C, it is 1, 4, 6, 10. So we're trying to unite these two sets. So in this case, A intersection B union C will be equals to, you just now combine these two sets. So in this case, I'm going to have 1, 4, 6, 8, 10. So basically, that is what I'm going to have. Then for the last one, it's not very different. It's just that in this case, this one was union C. Now we're trying to find the intersection. Okay, I think we can also solve it. So we have this is D, A union B. Let me write A union B in advance. So what is A union B? The union between the two. So I'm just going to write them. We've got 1, we've got 2, we've got 3, we've got 4, 6, 8. Okay, there's no 9, so there's 10. Okay, then there's intersection C. Let's first write C. C, we've been given 1, 4, 6, and 10. So now what do we now need to do? Let's now find the intersection. So we've got 1, 1, we've got 4, we've got 4 there, we've got 6, we've got 6 there, we've got 10, we've got 10 there. So A union B intersection C will just be those ones, 1, 4, 6, and 10. So those are our answers there. So we come to question number 6. Here we're taught to express each of the following in its simplest form. Okay, so we've got P complement union Q minus P. Okay, then we've got big square brackets, then we've got a complement outside. Okay, so you can start with what you have in the brackets. There are a lot of ways to solve this question, but what you should know is that what you have in the bracket Q minus P, this is called the difference law. In other terms, it's also called a relative complement. So this equates to Q intersection P complement. That is very important, especially as far as this question is concerned. So in this case, I'm going to have P complement union. Then I'm going to write the simplified version of Q minus P, which is Q intersection P complement. Okay. Then I have a complement outside there. I can solve what I have in the brackets. Then I take the complement, or I distribute the complement inside the brackets like that. So basically that. Now if I just want to solve what I have inside the bracket, what am I going to have? Now you should know something. There's what we call the law of absorption. Absorption is if I've got X union X intersection Y, this always gives me an X. Okay, this is called the absorption law, and I think it's okay, it's this one. Yes, it's the same thing. So what this means is that if I'm going to distribute X and with everything that I have in the bracket, it's just going to give me X here. Okay, it's called the absorption law. So if I'm going to look at this law and compare with what I have there, okay, so the P complement will just act as the same X. Then we've got union there, we've got an intersection. Then we've got Y. Okay, Y in this case will act as a Q. So even this one is absorption law. It's going to give us automatically a P. Okay, so basically that. Now it's going to give us a P for the reason that because if we solve whatever we have in the bracket, we're going to have a P complement, okay, as our answer. Then we have a complement outside. The complement and the complement, they'll just cancel out. You're just going to have a P, okay, instead of a P complement. Then let's solve the other one. We've got B. Okay, B we've talked about. The answer will just be X. It's absorption law. Then we've got M intersection N. Okay, union M intersection N complement. So how do we solve this one? Now remember a distributive law. Because for it to reach this end, it means it has been expanded. So let's take it back to the way it was. So this is the one that is common. Okay, so I'm going to put it outside. So I'm going to have M intersection. Then here there is N. I'm going to put my N. There's a union there. I'm going to put my union here. There's the N complement. I'm going to put the N complement. Okay. Now the question will be, what is the union between N and N complement? So if this is our set and I've got this is N, then this will be N complement. So you are going to realize if I'm finding the union, I'm going to get everything, and everything in that case is a what? It's a universal set. So in this case, it's just be M intersection the universal set. Now what is intersection? Just means what is found in both. What is I going to find in both in M and the universal set? Now you know that every set is a subset of the universal set. So in this case, our answer is just going to be M. Okay, so basically that is how we solve this one. Okay, so you can also try out C. So C is not, you can also try out we can even solve D. So D, we have A minus B. Okay, so even this one you have to know what that means. So in this case, I'm going to have A minus, we're saying this is a difference law to be A intersection B complement. Now we still have another minus, so we're going to again do the same thing. I'm going to have A intersection the same set A intersection B. There's a complement, don't forget. Then the minus is going to become a complement. Then what do we now do here? We just have to now distribute the complement again. So I'm going to have A intersection, I'm going to have A complement union B. Okay, why? Because of the De Morgan's law here, because of this complement. Then you just have to solve the two sets. However, you can also solve it just the way we solve it using the distributive law, because this is a distributive law. So A is going to go with A complement. So what am I going to have? I'm going to have A intersection A complement. Then don't forget you have the union there. I'm going to put my union here. Then again it's going to be A union. It will be A intersection B actually. Okay. Then what is the intersection between A and its complement? So there is nothing, right? If we draw a Venn diagram, this is A, then this is A complement. What are you going to find in both sets? There is nothing, right? So in this case it's an empty set. So an empty set union A intersection B. Now union, you're combining nothing plus something. You're always going to get something, right? So in this case I'm just going to have A intersection B. So that is our final answer. So you can try the other ones, but if you're going to look at A union B minus C, it's not different from what we are solving. So it will be A union B minus C complement. Okay, so for this one, since you can't even simplify it further, you cannot even go any further because these, all of them are different letters. So you can even leave it here, it's still fine. Now we come to question number 7. So for question number 7, use the combination of the brackets. So there's these ones, we have got these ones are called parentheses. So we've got parentheses there. Then we've got square brackets to write the sets. So let's start with the first one, A. We are saying X is a member of real numbers, and this X is in that region. So how are we going to write in terms of those brackets? Since X is greater than 7, greater than or equal to 7, and it is less than 13. So what do we do? So it means since it is greater than or equal to 7, 7 is going to be included. Okay. However, when we come to 13, what about 13? 13 is not going to be included because it is less than. So always look at the inequality symbol. So that is how we solve A. What about B? So X is greater than -4, but it is less than or equal to 13. So in this case it is the same thing. Since it is greater than -4, so in this case we're going to open where there's 4 and we're going to close where there's 13. So basically that. Then for C, X is a member of okay, so for C, all those angles, or let me say the ends, they are going to not be included. But now look at C, we have to be very careful here. We haven't simplified X, so let's simplify this one. We've got -6, we've got 3x, we've got 12. So what you're supposed to do, you have to first simplify this one, divide by 3 throughout. So I just have x on the middle. Now -6 divided by 3, that is a -2. Then we have with that. Then the 3 and the 3 are going to divide. They're just going to remain with x. Then 12 divided by 3, that is a 4. Okay. So in this case, what would be our final answer in this case? Since all of them are not included, so therefore x in this case will just be equals to -2 will not be included and 4 will not be included. These are set intervals. Okay. So that's how we solve C. Then for D, -6 greater than or equal to -2x is greater than or equal to, okay, then there is 4 there. So likewise, like we did to the previous one, I'm going to divide by -2 throughout. Okay, -6 divided by -2, that will give us a 3. Now we have to be very careful here. We were dividing by a negative, So inequality symbols are going to change. So this one is going to face the other direction. I'm going to have x there. Now this one was also divided by negative. The inequality symbol is going to change and it's going to be negative 4 divided by negative 2. That will give us a negative 2. So in this case, because all of them are included, our final answer is just going to be, you're starting from the smaller number, which is negative 2, then you're going to the bigger number, which is 3. Please never make a mistake of swapping them. You write like this, then you write like that. This will be very wrong. For set intervals, always start with the smaller one, then you go to the larger one. Okay, so the smaller one, then you go to the larger one. So but you don't use this arrangement. So that is very important to also stress on. Then I think we're done on this one. Let's go to question number 8. We're told to write each of the following intervals in set builder notation. Okay, set builder notation. Let's start with negative 1 and 1. That is A. In set builder notation, because negative 1 is not included, 1 is also not included. So therefore x will just be such that this x will be just the number of real numbers. Then if you're going to look at x, it is between, x will be greater than negative 1, but x is less than 1. So that is our set interval notation there, or set builder notation. Then we've got negative 6, 3 for B. Okay, so what do we do for B? So x will be a member of real numbers. Okay, so this x, it is greater than negative 6, but this same x is less than or equal to 3. Okay, why I've put equal to? Because of the square bracket part there. So this one is called an open closed interval. Okay, then we come to C. So for C we have negative 4 and 1. Okay, so you're able to see this one is a closed open. So how are we going to write it in terms of set builder notation? So x is such that x is a member of real numbers, and this x should be greater than or equal to negative 4, then this x should be less than 1. Okay, so basically that, because this is included, it's closed, then it's open, so it's called a closed open interval. So because here it's closed, you're going to include the 4. That's why we have, you're going to include the negative 4. That's why we have the equal to sign there. Then here it's open, so we're not going to include 1. That's why I'm saying x should be less than a 1. Then we come to D. How do we simplify D? So for D, we have 3 to okay, so that is 3. Then we are going all the way to positive infinity. So in this case, what would be x? X would be a member of real numbers. Okay, however, this x, well, we are able to see that x is greater than 3. Why is greater than 3? Because we are going all the way to positive infinity. So it means we are starting from 3, which is the smallest number. Like I said, you're always starting with the smaller number, then you're going to the bigger numbers. So in this case 3, so x will be greater than 3. We've put greater because 3 is not included. So that is our set builder notation for this one. We come to E. Now for E, we've got negative infinity to 1. Okay, so what do we do there? So E, it is negative infinity and 1 there. So we're always starting with the smaller one. So negative infinity is smaller, then we're ending at 1. So in this case, what would be our set builder notation? So this one, x will just be a member of real numbers. Now this x should be less than or equal to 1. Okay, why? Because all the numbers are going to we can start from negative infinity, but the highest number of x that you can have is a 1. So x should be less than or equal to 1. So that is how you solve this one. Then question number 9, we're taught to display each of the following intervals on the real line, okay, or on the number line. So now how do we draw this one? So let me just use these ones. Let's say, let me draw just a general number line. So this is what we're going to be using. And what are the numbers that we have here? We've got okay, let me just write all of the numbers, and we're just going to be using the same number line. Okay, let's say that is our number line. We have negative 10. The lowest that we have is negative infinity. We've got negative let me start with the negatives. We've got negative 10. We've got negative 1. Okay, I think the negatives are done. I can now start with the numbers. We've got 0. We've got a 2. We've got a 5. We've got an 11. Okay, let's say we've got a 10 first, then we've got an 11. Okay, then we've got positive infinity. So if that is what we have, what do we now do? I'm just supposed to now do, so A, we're saying it is negative 10 to 10. Okay, so from 10 I'm moving all the way to 10 there. Now if we're going to look at A, this is open, this is closed. So this is called an open closed interval. So in this case, at negative 10 I'm going to open. However, at negative 10, at positive 10 there, I'm going to shade like that. So negative 10 I'm opening, positive 10 I'm shading like that, because positive 10 is included. That is for A. Then for B, we are moving from 2 to 11. Then if you look at B, all of them are included. It's a closed interval, okay, notation. So at B I'm going to shade, at 2 I'm going to shade, and at 11 I'm going to shade. So that is how we solve this one. Then we come to C. C, we are moving from negative 1 to 5. Okay, now if you look at C, negative 1 is, it's open. Okay, so I'm going to open there. Okay, so I'm going to open at negative 1. Then at 5, you're able to see that it is closed. So in this case, I'm going to shade like that to show that it is closed. So that is how we solve C. Then we come to D. For D, we are moving from 0 to, we're moving from 0 to positive infinity. Okay, since we don't know where infinity ends, however at 0, since it is closed, I'm going to shade there. Then we're going all the way to positive infinity. I'm just going to put an arrowhead there to show that we are going to go like that. We don't know where we end. Okay, for infinity you don't know where you end. That's why there's always an open interval sign there. Then we come to E. E, you are moving all the way from negative infinity to positive infinity. So you can just start from anywhere, but make sure that you're going all the way to positive negative. You are moving from negative infinity and like that. So on both directions you are going like that. So that is how we show these ones. Let's solve question number 10. So for question number 10, we're taught to let R be the universal set and A is equals to that, B, that, and that. Then we're taught to illustrate each of the following sets on the number line, hence to find each of the following sets. Okay, we're taught to to illustrate each of the following sets of the on the number line, hence find each of the following set. Okay, so yes, you have to first show these sets on the number line, then from there that's how we'll be able to solve. So we can also draw a number line here. Okay, so for these ones we're just going to pick maybe 1 or 2, then the other ones, the rest you can solve. Okay, so we have A minus C. So let's start with A. A, we are moving from -6 to 1. If I say -6 is here, and if I say 1 is there, so you're able to see that -6 is not included. I'm going to open, then 1 is included. I'm going to shade. Then I just have to join these ones. Let's say this is our A. Okay, let's say this is our A. Okay, that is our A. I'm going to write it as A. Then B, it is from 0 to 5. If I put 0 here, then I put 5 there. So 5, 0 is included, 5 is also included. I'm going to shade on 0. I'm also going to shade on 5. Then I just join the two like that. This is B. Then C, if I'm going to look at C, we're moving from -9. If I put -9 here, and I put 8 somewhere there, okay, now I'm able to see that -9 is included, but 8 is not included. So at 9, because 9 is included, I'm going to shade. However, at 8, I'm not going to shade. So I'm going to join it like that, or I just write it like this. Okay, that is like that. Let me also just highlight for B. Okay, like that. So this is how it's going to be. At 8, I'm not shading. Then the first question is asking us, we've illustrated everything on the number line. It's asking us to find A minus C. Okay, now you have to first find what C is. And okay, A minus C, we are saying this is a difference law. It's just the same as A intersection C complement. So trying to find the intersection between A and C complement. So C is here. C complement, it will be C complement, it is at 8 going this direction, and you know, -10 going the other direction. So basically then A is here. So there is no intersection between the two, because these other ones they're just far away from this region. So here for A minus C, it is an empty set. Then we come to B complement. We come to which one? B. So we've got B complement intersection. Then we've got B complement intersection. Then there's another complement outside. Okay, so there are a lot of ways on how you can solve this one. You can find what B complement is, and you also find what C is, and after that you find the complement for that, or any other way. Okay, so in this case, let's find out what B complement intersection C is. So B complement, let's start with B. So B in this going in that direction, this will be B complement, and another part of B complement is here at 5. Okay, 5 is not included. We're going all the way to 8. Okay, 8 there. Since 8 is not part of the universal set, I presume. Okay, we haven't been given a universal set. We're going in that direction. Now, we're trying to find the intersection between B complement and C. Oh, so this is C. So the intersection, therefore, to be this part and the other part there. Okay. So in this case, what then will be the the complement there. So if B complement intersection C, it is just, we're just ending there, by the way. We're not like proceeding because that's where C is. So the intersection between the two, you're able to see that it is -9, or yes, actually it's from -9 is part of C, -9 is also part of B. Okay, so in this case, B complement intersection C, then there's a we haven't put the complement first. We're going to put it at the end. So the intersection, we're able to see that it is -9. -9 is included. Then we're going to reach here. There 0 is not included in B, so I'm going to put 1, and I'm going to put like that. Then 1 is not included. Yes, hope we are accurate. B is from 0 to 5. 0 is included in B. So if we're going to look at it, since 0, okay, B 0 is included, C 0 is also included. Actually 0 is found in both. Okay, so in this case, I'm just going to have, we've put the 0 there, and I'm going to open like that, union. We're going to come to the other side. The other side, we have at 5 is included in B, 5 is also found in C. So 5, then all the way to 8. Now 8 is not found in C, but 8 is found in B. So we're going to 8, and we're going to open like that. Now, if we're going to now find the complement, we're supposed to find the complement of what we have here. Okay, so the complement therefore is going to, from here going all the way to the other direction, and then from here between this part and this part, then from here you shade there, and you're going all the way to that side. That would be our final answer. So in this case, what then is our final answer? So let's find that. So since we are going all the way from this direction, this is from -infinity to -9. Then we have you're going to say union. We come to this middle part. What about that middle part? We've got 0. Okay, then we've got 5. Then what other thing do we have? We are going to say union. Now 8 is not part of C, so it's going to be part of the complement 8. Then you're moving all the way to positive infinity. So basically this is how you're going to solve this one. So of course you can also solve C and B complement. They are not very much complicated. It's the same concept. Let's look at the last question. So let X is equals to that, be the universal set, and A is equals to that, and B is equals to that, and C that, be its subsets. Find each of the following sets and illustrate them on the number line. So basically that is what we're just from solving. It's not different from the previous one. So let's just solve the first one. So in this case we've got C minus A. So in this case, when you simplify this one, it's going to be C intersection A complement. C intersection A complement. So we're just supposed to find that, but of course we have to first draw our number line. Let's say this is our number line. Then on our number line, we're going to put, we're saying C. C is from -40 from -4. So let me put -4 here. Then 7, let me put 7 there. Then since -4 is not included, I'm going to open. However, 7 is included, I'm going to shade. That is C. Then I come to A. A is from -6. If I put -6 here, all the way to 1. If I put 1 there. So, and all of them are included, I'm going to shade on 6, and I'm going to also shade on 1. This is A. Then I'm trying to find the intersection between these two sets. So you're going to realize that it's just this part. Okay, so that is the part that is C intersection A complement. Now let's also include B, because we're also uniting this part with B. B is from 0. If I put 0 here to 5, let's say 5 is there, and if I write 0 is not included, then I'm going all the way to 5. 5 is included. I'm going to shade there. Now you're able to see that the intersection between C intersection A complement and B is just this part, and that's the solution that we are looking for. Okay, so what is that part that we have there? So now you're able to see that 0, if we're saying this is B, 0 is not part of B, okay, but it is part of the intersection of A complement and C. So in this case, our final solution of C minus A intersection B will be equals to, since 0 is not part of B, it's going to be part since B starts from, it doesn't start from 0, it starts from 1 actually, because 0 is not part of B. So in this case, we're just going to say, put it like that, and then we're going to move all the way to 5. Now 5 is 5 included? No. Okay, so in this case we're just going to have 5 like that. Okay, 5 is also part of B. So basically this, yes, basically that. So there are a lot of ways on how you can solve most of these questions. They are not really complicated. Yeah, so there are a lot of ways on how you can solve, these questions. So basically that, I think we've solved most of the questions. So for the other ones, you can just try out. They are not very much complicated. So thank you, and we're going to see you in other sessions. Please don't forget to subscribe to our channel.